I am Geeta, working as an assistant professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchengodu. Course name is Statistical Methods. In this course, we have 5 modules. The first module is Probability and Distribution. First topic is Random Variables. A random variable, usually written as x, is a variable whose possible values are numerical outcomes of a random phenomenon. Types of random variable. There are two types of random variables. One is discrete random variable, the another one is continuous random variable. Discrete random variables. A discrete random variable is one which may take on only a countable number of distinct values such as 0, 1, 2, 3, etc. Discrete random variables are usually counts. In real-time example, number of children in a family, Friday night show count in a cinema theater, count of patients to a doctor per day, the number of defective light bulbs in a box of 10, the number of hits flipped in 3 trials. Probability distribution. The probability distribution of a discrete random variable is a list of probabilities associated with each of its possible values. Consider tossing fair coins 3 times. X is defined by the number of hits obtained. Tossing a coin 3 times, all the times we getting tail means the options are tail, tail, tail. So the corresponding x value is 0 because in that case there is no head occurs. So x value is 0. If suppose tossing a coin 3 times we get only one head means the possibilities are head, tail, 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 head, tail, 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 head. Here the corresponding x value is 1 because in each case the head occurs one time. The next option is tossing a coin 3 times, we get 2 heads. The possibilities are head, head, tail, head, tail, head, tail, head, head. So x value is 2. The last option, all the 3 times the coin tossing, we get only head. So x equal to 3. So the values of x are 0, 1, 2, 3. In 0, the corresponding probability, already we know that the probability is nothing but number of favorable event divided by total number of possible outcomes. Tossing a coin 3 times, the total number of possible outcome is 8. Out of 8, the value of x equal to 0 is 1. So the corresponding probability is 1 by 8. Value of 1, the corresponding probability is 3 by 8 because here 3 options are there: head, tail, 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 head, tail, 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 head. This same thing, value x equal to 2, the corresponding probability is 3 by 8. The last option x equal to 3 means the corresponding probability is 1 by 8. So the values of x are 0, 1, 2, 3. In x value is 0, the corresponding probability is 1 by 8. 1, the corresponding probability is 3 by 8. 2, the corresponding probability is 3 by 8. 4, corresponding the probability is 1 by 8. Probability distribution of discrete random variables. A discrete random variable x takes a fixed point of possible values with a gap between. The probability distribution of a discrete random variable x lists the values xi and their probabilities pi. Values of x is denoted by x1, x2, x3, etc. and the corresponding probabilities are denoted by p1, p2, p3, etc. The probabilities pi must satisfy 2 requirements. One is every probability pi is a numbers between 0 and 1. The second thing, the sum of probability is 1. To find the probability of any event, add the probabilities pi of a particular values xi that make up the event. For an example, A random variable x has the following probability function. X values are 0, 1, 2, 3, 4. Corresponding probability value was k, 3k, 5k, 7k, 9k. First option is find the value of k. Second option, find p of x less than 3 and p of x lies between 0 and 4. The first option, find the value of k. K is in the probabilities values. So, we know that total probability is always 1. So, adding all the probabilities and equating to 1, we get the k value. That is, summation p of xi equal to 1. P of x values are k, 3k, 5k, 7k, 9k. Adding all these things and equating to 1, we get the k value was 1 by 25. The second one is p of x less than 3. Here in given data, x values are 0, 1, 2, 3, 4. X value is less than 3 means the possibilities are 0, 1, 2. So, p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2. The corresponding probabilities are k plus 3k plus 5k. Adding all this we get 9k. K value already we calculated 1 by 25. Substituting here we get 9 by 25. Next one is p of 0 less than x less than 4. In given x value 0, 1, 2, 3, 4, x lies between 0 to 4. The possibilities are p of x equal to 1 plus p of x equal to 2 plus p of x equal to 3. The corresponding probabilities are 3k plus 5k plus 7k. The total is 15k. K value is already we calculated 1 by 25. Substituting here we get 15 by 25. Simplify this we get 3 by 5. Continuous random variable. A continuous random variable is one which takes an infinite number of possible values. Continuous random variables are usually measurements. Example, height, weight, the amount of sugar in an orange, the time required to run a mile. Probability density function of continuous random variable. The probability density function of a continuous random variable x is denoted by f of x. And f of x satisfies the following condition. The first condition is f of x is always positive. That is, f of x is greater than or equal to 0 for all x belongs to R. The second thing, total probability is 1. In continuous case, the total probability we may calculate integral minus infinity to plus infinity f of x dx equal to 1. The third option, p of a less than or equal to x less than or equal to b. That means here integral, the lower limit is a, the upper limit is b. So integral a to b f of x dx. Fourth option is p of x equal to a. X is equating to some event, the value is 0 for continuous case. For an example, given that the probability density function of a random variable x is f of x equal to kx, 0 less than x less than 1. Find k and p of x is greater than 0.5. The first option is find the value of k. We know that the total probability is always 1. In continuous case, the total probability is integral minus infinity to plus infinity f of x dx equal to 1. So, here the given interval is x lies between 0 to 1. So, integral 0 to 1 kx dx equal to 1. K constant take outside. Integration of x we get x squared by 2. Substituting the upper limit minus the lower limit and equating to 1, we get the k value as 2. Second one is p of x is greater than 0.5. X is greater than 0.5 means 0.5 as a lower limit. So, the integral value is integral 0.5 to infinity f of x dx. In the given problem, x lies between 0 to 1. So, the upper limit is 1. So, integral 0.5 is denoted by 1 by 2, 1 by 2 to 1. 2x into dx. K value is 2. Substituting here we get 2x into dx. 2 constant take outside. Integration of x we get x squared by 2. Substituting the upper limit minus the lower limit we get the value as 3 by 4. Thank you.